Next, we look into software migration. One would consider software migration when one cannot simply do with wrapping. So software migration is long and more expensive re-engineering project and more complex process than just wrapping. However, you have some advantages. You gain better understanding of the system as you work longer on it. It's usually better maintainability. It reduces cost in the long run, most likely. And there is a more flexibility for future, because with wrappers, you might be stuck in with what the wrapper does, but with migration approaches, you can do more. You can satisfy better the future customer needs. Migration involves changes but retains the basic functionality. And this is a big difference to the wrapping again, where you just wrap something around it and don't do any changes to the legacy system. In migration, you actually try in the end to get rid of most of all of the legacy system component. Okay, so we have two basic approaches. We have the big bang / cold turkey / rewrite, and then we have the chicken little iterative. So if we start on with the big bang or cold turkey or rewrite, you replace the whole system at once, and you do this if the re-engineering project cannot be split to different tasks. This is usually a good approach for smaller legacy system with stable and well-defined functionality. Advantages are it doesn't require a lot of management, so you basically just develop a new system that replaces the old. So there is no hassle of running two systems side by side, for example. Disadvantages, it's a monolithic task, so something might go wrong when you replace the new system. It takes time for the new system to be visible, so you cannot deploy it in iterations. And the risk of failure is higher as you do not do any iterations along the way, and you don't deploy these components to the production environment. So something might go wrong when you do, in the end, deploy those. So then we have the chicken little / iterative approach. And if someone is wondering about the name, this chicken little apparently comes from some Disney cartoon where Chicken Little is a very young hero who saves all with his cautious and conservative character. So cautious and conservative are the key approaches here with the Chicken Little. In this approach, the systems exist side by side. So you run the old system and new system side by side. And you do very cautious and conservative iterations. So each iteration of the process happens in a short time frame. You might, for example, re-engineer only small part of the system. For example, it might only be a single class or even a single function. You might also want to group the existing components by functionality and engineer a bit of a bigger part of the components at once. So you can have different lengths of iterations, but the idea here is that you are cautious and conservative and replace the old system a little bit at a time. And as you do this side-by-side operation where you replace the old system with the new system, you have 4 types of components. You have old components from the legacy system that you have not yet re-engineered. You have components currently being re-engineered that you are currently working on, components already re-engineered, and then you have new components that do not come from the legacy system. So this is the components that where you alter the functionality or you bring something new to the table. Benefits of this approach is that, well, continuing service of the system and the familiarity with the existing system is preserved. Disadvantage is that you have to manage different type of components, and another disadvantage is that you have to manage the system side by side, which can cause a bit of a problem if you are not very careful what you are doing. And the best way is to think these two approaches as the ends of a continuum. So in one end, you would do of the continuum, you would do a complete system rewrite, cold turkey, everything at once. And in the other extreme, you will do as tiny pieces as possible in the iterative or chicken little. So you might only convert one function at a time or one class at a time. And in the other extreme, you do everything. So, but then there are options in the middle as well. Let's say your system nicely divides to 5 components. So then you divide the migration approach to 5 rewrites. So it's no longer a, complete rewrite, but you do 5 rewrites at the time. So you are partially being more careful here. And on the other hand, from the Chicken Little approach, instead of doing one class at a time, you could do collection of classes at each iteration. So this is already closer to the doing as small components as possible. So these two approaches are presented here, Chicken Little, Big Bang, they are like the ends of this continuum. And then you can do everything in the middle as well. You might even do, let's say you decide to do 5 rewrites, but you decide that I will do, or the project will do 5, for these 5 rewrites, they will do each one class at first. So before you beginning any of these rewrites, you rewrite one class as a sort of a risk management approach. So one class is first rewritten, tested, implemented, and so on, and only then you continue with the rewriting of the rest. And then you do 5 of these. So you could combine. You could have as tiny piece as possible to do like a prototype or architectural spike type of testing. So this would be like a risk management approach. So you first do a very little piece. If it goes fine, then you continue with the approach of the rest of the classes, for example. So you can combine these approaches from each end to come up with the best solution. And the choice of these two or in this continuum is not only influenced by what you want to do and what is the best, it is also influenced by the legacy system. So if the system is fully decomposable, you can easily find different user interface pieces, different application logic pieces, different areas in the database. So it's fully decomposable, then you can basically do anything that you like. Then this semi-decomposable system would be something where you can find some pieces. So you might be able to separate the user interface, but you might find that the application logic and the data are mingled so that the application logic and the data cannot be separated from each other. This might be due to the fact that the system doesn't use database. It has a flat file structure, for example. Or it could be that the system has a database, but then the application logic and the user interface are sort of meshed up together. So you cannot really separate the user interface from the application logic. And finally, you have systems that are not decomposable at all. So in those cases, you would most likely lean towards the Big Bang type of renewal, as you cannot really separate any pieces that you could gradually replace from the legacy system. Okay, let's have a look at a bit of the different migration techniques or the more detailed migration approaches, now that we have the Big Bang and the Chicken Little as the extremes out of the way. So a database first system would start out by first renewing the database. So you have a target database and then you have a bunch of legacy components. So you start from the migration project that you do a new database. And you get to the new database by doing first database schema conversion. You translate the new technology, you have a better structure. Then you do data conversion. You extract, transform, and load the data to the new database, do data cleaning. Then you do gateway building. You don't change any functionality, you just build a gateway for the old legacy components to access the database. You do testing of the functionality, regression testing. You shouldn't introduce any new functionality in the database, but in practice, this might often happen. And after this step, well, you are happy, you have your new database, you also have your new gateway, and your system looks like this. And now you can continue migrating to the new system. So the next step in your system would look like this. So this is in the middle of the database first migration approach. So first, everything is here, old legacy, and you have the gateway or wrapper, you could also say. There is in practice very little difference between the gateway and the wrapper that was introduced previously. So, but the next step is that you migrate some of the components to the new system. So you replace some of these components and you introduce them on top of the target database. And you keep converting these old components to the new components until you run out of old components. So in the end, your system would look like this. You have a new database, new data, and all of your components function directly on top of the new database service. So that was the database first approach. So the database last is basically the opposite. You start out with the legacy database, legacy data, and as a first step, you develop a reverse gateway needed to migrate your first components. So the benefit of this approach is that the reverse gateway can be built bit by bit. So you develop your first component, the module K, and you develop the necessary functionalities on top of the reverse gateway. Then you continue by taking the next component and so on. But you continuously operate on top of the legacy database, but you have new applications on top of the legacy database. Okay, so you continue migrating your components, and almost in the end, it looks like this. So you have no legacy components, but you still have the reverse gateway and you have everything with the new technology. But you do have the old legacy database that you need to get rid of. So what is the benefit of this approach is that once you have migrated all of your components, you have pretty clear understanding how the legacy database works. And now you can do excellent design on the new database. And perhaps this wasn't possible with the database first approach, because you migrate it first and then you might not know what happens in all the applications. So with this approach, in the final step, the database first and the database last look the same. There is no legacy components left. Everything is on top of the new. So this is the last step. But with the database last approach, you might end up with the better database structure, because you do it at last, and because that is then difficult to change also in the final system. For the database first, well, put it this way, in the database last, you continuously have to live with the old database. That might be slow, that might have problems, that might have difficulties. So you don't immediately get the benefits of the new database in the database last approach, which in fact, in the database first approach, obviously you get the benefits from the new database to the new components as you migrate them. For both type of approaches, you need to have decomposable systems where you can separate the database, the user interface, and so on. Otherwise, this cannot work very well. Database first and database last approach can be done simultaneously with sort of what is called a composite database approach. So here you have legacy components in white and legacy database, but you also start to do new components, while you have also at the same time have the target database as well. So if a legacy component makes a request, the coordinator determines using the mapping table whether it should go and get data from the new database using forward gateway, or whether it goes directly to the legacy database. And vice versa, for the new components, it figures out whether it should go through reverse gateway to the legacy database, or whether it can go directly to the target database, as this is a sort of a new component. So in an ideal case, most of the calls from the legacy components should go directly to the legacy database, and most of the calls from the new components should go directly to the target database. So there would be lesser use for these gateways. They would be still needed for some cases, but ideally they should be used less. And over time, of course, these legacy components would be completely replaced by these new components, and at the same time the usage of the legacy database would lesser. If there is a need to have And this approach also allows to have duplicated data. So you might have some data that is in both places at the same time, if it is needed in the new database and in the last database. So what to do if your legacy application is not decomposable? So in this case, you have Composite with non-decomposable legacy system. So you have a legacy application and database bundled in as one. So the legacy application and database cannot be separated from each other. So then what you do is that you separate the external interfaces, like the system interface, that is to another system, or user interface, and you put it on top of what is known as an application gateway. And then you have this legacy mesh with the legacy application and database services underneath that. And the legacy interfaces are on top of it. And the new interfaces, the new target system interfaces are also on top of it, but they stand on top of the application gateway. And if they need to access something from the legacy applications, they go through this application database. In this case, we cannot separate the database and the application in the legacy side, but we can do it on the new side, on the target system side. And finally, if you cannot even separate the user or the system interfaces from the legacy side, you have to install an information system gateway on top of the user interfaces and the system interfaces of the legacy system. So then you have the end users and the external systems on top of that. And for example, for the user side, you might run something like a screen scraper wrapper on the information system gateway that then accesses the legacy system. And then you run simultaneously, you run the new components, the new user interface systems as a separate branch. But this is for the cases where where the legacy system is a complete monolith. And this would then rely on building wrappers around the legacy system to access it from the information system gateway. So as you can see, depending on how decomposable the legacy system is, it affects the approaches you have to take when doing the migration. So finally, we have the butterfly, which is a technique developed not for simultaneous living of the new system and the legacy system. So the idea here is that the legacy system is in the end replaced by the target system at once. However, Butterfly solves the problem that you don't want to have a lot of downtime when you move from the legacy system to the new system. So how this goes is that you keep the legacy system as it is as you start developing the new system. So you keep everything here frozen and you develop the new system, and you bring some data for the new system for the testing from the legacy one. And once the target system is ready, then you start to migration. But during the migration, you want to minimize the downtime. And how you do minimization of the downtime is that first you write everything in the legacy data store and you copy it to the new database while you continue to operate this legacy system. Now, how that can work is that this legacy data store is frozen, but you have a temporary data storage here, and you do writes and reads from there if necessary, if modifications are needed. So you do it from here, and once this legacy data store has been completely modified, then you froze this temporary data storage, and you do the new operations on the temporary data storage number 2. So then you push the changes you didn't have in the legacy data store, and if there are new changes, they are made to this legacy, to this temporary storage number 2. And once this temporary storage 1 has been converted, then you freeze the temporary storage number 2. And the new changes come to the ever succeeding number of temporary storages. And finally, in the very end, because these data storages would get smaller, like this legacy data store, the first step would be the largest. So then it might take an hour, but during this hour, some modifications would happen, and then those would be written to the temporary data storage. And well, okay, converting this temporary data storage might take 10 minutes. And during these 10 minutes, there would be some changes that have come to the temporary data storage number 1. And well, conversion of that would take 1 minute. So you would have ever smaller number of this temporary data storage. They will get smaller and smaller. So basically what this approach allows is that you have a minimal downtime when you move from the legacy system to the new system. And this is a handy approach if you have a massive amount of data store that you have to move to the new system. So then you can keep operating the legacy system, and then finally you have to do maybe like a 1-minute break when you switch on everything to here, when you close the final one and say that no more changes at this time. So maybe it's down 1 minute, and then you move everything to the new system.